Today we're going to start talking about the organic molecules. You'll also hear them called biomolecules because these are the building blocks of life, the building blocks of living things. For something to be considered an organic molecule or a biomolecule, it must contain one element, and that is carbon. If it doesn't have carbon in it, it is not considered organic or a part of life. There are three other really important elements that can be found in these biomolecules, but they are not essential. They must have carbon for it to be considered organic. The other three are hydrogen, oxygen, and nitrogen. So a lot of people will use CHON. That's their keyword to help them remember the big four, CHON. C-H-O-N, for carbon, hydrogen, oxygen, and nitrogen. Another term that you may hear used to refer to these large biomolecules are macromolecules. Macro for large, because they contain hundreds of atoms of these four elements. There are four groups of organic compounds that we are going to study. They are the carbohydrates, the lipids, the nucleic acids, and the proteins. In this video, we will just cover carbohydrates. So I want you to think for a second and try to think of any carbohydrates that you know of. What can you eat if your body needs carbohydrates? Okay, hopefully you came up with something like this. Sugar, so ice cream, gelato, cookies, muffins, candy bars, fruits, and then your grains, your breads, and your pastas. So if you need carbohydrates, you can eat any of these things. Carbohydrates, if you were to give them a nickname, they would be called the quick energy molecule, referring to their job to provide your body with fuel, energy, and to do so quickly. Carbohydrates are made out of only three of our big four elements. They have carbon, hydrogen, and oxygen. That's it, nothing else, just carbon, hydrogen, and oxygen. But these elements, the carbon, hydrogen, and oxygen, they come together in a very specific way to make a carbohydrate, because these three elements make lots of other things too. But for it to be a carbohydrate, it's going to come together in a specific ratio and a specific shape. So it's going to create the building block of a carbohydrate. The building block, or the beginning of a carbohydrate, is known as a sugar. And we're going to bring together large carbohydrates through a process called polymerization. Poly meaning many. So polymerization means to build from many pieces. So how do you make a carbohydrate? Well, you take a sugar and you connect it to another sugar, and you connect it to another sugar, and you have made a carbohydrate. And every time you add a sugar, you change the identity of that carbohydrate. Carbohydrates' specific ratio is 1 to 2 to 1. So since carbon is the essential element that makes it organic, when we talk about the ratio, we make it in relation to carbon. So for every carbon that a carbohydrate has, it also has 2 hydrogens and 1 oxygen. So for example, if a carbohydrate has 4 carbons, well then it's going to have 2 times 4, or 8 hydrogens, and 1 times 4, or 4 oxygens. Okay? So 4 carbons, 8 hydrogens, 4 oxygen. That is always, that is true for every single carbohydrate. It always has that ratio of carbon to hydrogen to oxygen. A skill that you need to be able to have is to recognize a carbohydrate from an image. So that's why I have several pictures here for you to look at. Notice those sugar rings, okay? They might be hexagons, they might be pentagons, but they always come back together into a ring. They don't just form a straight line of carbons, hydrogens, and oxygens. They're always in a ring shape. And then those rings are hooked together, okay? So make sure if I give you an image, you can go, oh, that's a carbohydrate because I see sugar rings in it. So now we know carbohydrates are made of sugars. And we've already talked a little bit about their job, their function. So their job is to provide the body with quick energy. When you eat a candy bar, in a few minutes you start to feel better, you start to have more energy, you get that sugar rush, because that's what a carbohydrate's job is. Sometimes you'll also hear it said that they have short energy storage. These are your complex carbs, like your starches, your breads, and your pasta. Your body can actually store that energy for a very short amount of time, usually about 24 hours. So sometimes you'll know people who run marathons. Well, the day before a big race, they'll eat a giant bowl of pasta because the body can store that for up to 24 hours. So that'll be fuel for their body during the big marathon the next day. Football players also do this. They tend to have pasta dinners before a big game. Plants can also use carbohydrates for structure. So there's a special carbohydrate that gives plants its rigidity, that makes them rigid and stand up. Some examples of sugars or carbohydrates are sugars. So table sugar, any type of thing that you can think of with sugar, such as candies and muffins. Starches, so your breads and your pastas, these are also carbohydrates. And then that special one I was talking about that plants use for structure is called cellulose. Okay, that's what makes up their cell wall, which we'll learn about soon. A special little helpful hint that you can use, sugars almost always end in ose. So their scientific name ends in ose. Here are some examples. Glucose, which is what plants make during photosynthesis. Fructose, which is what is in all fruits that make them sweet. Sucrose, which is your table sugar that you put in coffee and tea. And maltose, which is the sugar that they use in beer, and they also use it in malt shakes to make it thick and creamy. Okay, so notice all sugars end in ose. So in the future, if I give you a list of chemical names and I say which one is a sugar, look for the one that ends in ose. That's your clue. That's a sugar. That's a carbohydrate. There are two major groups of carbohydrates. The monosaccharides, mono meaning one. Monosaccharides are very simple because they are made of one single sugarine. Some examples are listed here. Fructose, which is found in fruit. Galactose, that's one of the ones found in milk. These are really easy for your body to break down and use the energy quickly. You can put two sugar rings together, and that's called a disaccharide. Or you can put together three or more. We're going to call that a polysaccharide, poly for many. These are very large carbohydrates, and they're made from lots and lots of sugar rings. Some examples that are important are glycogen. Glycogen is stored in your liver, and it is used when you exercise to fuel your muscle movement. And the other one, of course, being cellulose, which is what plants use.